So today we are resuming on page 3 where we left off with number 22. So we used our P over Q values to find one root, that non-exact in-between root. And once we have a root, what do we do with it? We put it in the box. So I'm going to put negative 1/5 in the synthetic division box. And we are going to depress our polynomial. So we've got 5 and negative 9 and negative 12 and negative 2. And remember, you can use your calculator to multiply the fractions, but since our remainder is going to be equal to 0, it should work out pretty nicely. So a negative fifth of 5 is negative 1. Negative 9 and negative 1, adding straight down, is negative 10. A negative fifth of negative 10 is positive 2. Negative 12 plus 2 is negative 10. And negative 1/5 of negative 10 is a positive 2. And that gives me 0. So what this has done is it has taken my degree 3 polynomial and depressed it down to a degree 2. And remember, that's kind of our goal, is to get it down to a degree 2, because once it's degree 2, it's a quadratic, and we've got the quadratic formula or square root to work with. So let's go ahead and just look at this equation. We've got 5x squared minus 10x minus 10 equals 0. So from here, can we take out a GCF? It's never a bad idea to try to factor, especially with a GCF, because that does make your numbers smaller. So we can take a 5 out as a GCF, which leaves me with x squared minus 2x minus 2. Now, if I try to factor that, product of negative 2, sum of negative 2, that is not going to work. So what do I do when I can't factor further and when I need to solve a quadratic? We use the quadratic formula. So I'm going to sidebar up here. Let's go ahead and we're going to use these new smaller values in the quadratic formula. So x equals negative b, negative 2, plus or minus the square root of b squared minus 4 or 1 negative 2 all over 2 times 1. And now the simplifying part. So a negative 2 becomes a positive 2. Then we have plus or minus. Underneath the square root, we get negative 2 times itself, which is 4. And then negative 4 times 1 times a negative 2 is 8. So 4 plus 8 is 12. Or you can use your calculator. All over 2. Now, from here, can I take radical 12 divided by 2? No. Only outside numbers, outside of the radical, can we divide by 2. So from here, folks, we still need to ask ourselves that question of if there are any perfect square factors we can take out of 12. Is there a perfect square factor? Yeah, we can break that up into 4, which is a perfect square, and then 3, all over 2. So then 2 plus or minus the square root of 4 is 2. Square root of 3, all over 2. And then I can do division distribution. Now, when I do division distribution, 2 divided by 2 is 1. 2 radical 3 divided by 2, those 2's cancel, and leaves me with the square root of 3. And how many total roots did we find? 1, 2, 3. And what's nice about getting these non-imaginary roots is you could trace that on your calculator and do 1 plus radical 3 and see that it gives you 0, and 1 minus radical 3 and see that that gives you 0 as well. So folks, on these problems, if you can factor, you should factor, but on some of them, you will need to use P over Q values or your calculator to find a root. So let's go ahead and approach number 20 from the top. First thing that we do in these problems is identify the degree, because that represents the total amount of solutions we will have. So this has a degree of 3, so we're looking for 3 roots. our first plan of attack is to try to factor this. Do we have a GCF we can take out of everybody? No. There are 4 terms, though, which prompts me to try splitting it in half and doing factoring by grouping. So let's go ahead and take a GCF out from the first group, which would be x squared. And that would leave me with 4x plus 5. Now, GCF for my second group, I guess we could take out a -1, which will leave me with positive 8x plus 9. Are we going to be able to factor this using grouping? No. It's good to try, but wah, wah. Because those parentheses aren't the same, we're not going to be able to factor it out as a GCF, which is what puts it in that factored form. So, sad face. So, what should we do now? Do we jump straight into using P over Q values? Third block thought yes, but actually, even though we can't factor it, it doesn't mean that we're totally desperate to use our P over Q values. If I type this in on my calculator, in the y equals 4x cubed plus 5x squared minus 8x minus 9. Even though I can't factor it, I might still be able to pull off some exact roots from the graph. So, do we know any of our roots exactly? Definitely not that one. That one looks like it's right at -1. That one's between tick marks 1 and 2. So again, folks, I would recommend on your test just doing a happy little sketch of what you have. That way, if you happen to type something wrong in on your calculator, hopefully I can give you some partial credit. So we go up, we go down, and then we go up. So as I said, it looks like -1 is an exact root. So if I hit trace and hit -1, we see that, yup, we get an output of 0. So -1 is definitely a root. So sweet, I've got a root. Do I need to use P over Q values? Nope, not yet at least. Once we've got a root, we put it in the box. So -1 in the box. We're going to try to break down that polynomial to be a quadratic. So 4, 5, -8. -9. Always start by bringing down that first term. 4 times the box, add straight down. 1 times the box, and straight down. -9 times the box, add straight down. Woo! And what we have now is the degree 2 polynomial. So our starting degree was 3. When we synthetically divide, we always bring it down by 1. So now I have 4x squared plus 1x minus 9 equals 0. So we've got a quadratic. There's no GCF that we can take out. We know that they're not going to be imaginary, but these don't necessarily look like they're going to be friendly roots. You could try to factor it, but I'm just going to go straight to using the quadratic formula. So x equals -b plus or minus the square root b squared, 1 squared, minus 4, 9. 9 is negative. All over 2 times 4. I want you to try to simplify this one on your own. Start by simplifying underneath the square root. See if you can simplify that square root, and then division distribution. So when you type that in on the calculator, you should get 145 under the square root. Now, as far as simplifying that radical, I would probably try dividing it by 25, since 25 is a perfect square ending in 5. Ooh, but it doesn't go in evenly. So sometimes if I'm having trouble finding perfect squares, I'll just divide it by any factor, not a perfect square factor. Ooh, and what we'll see is 5 and 29 are the factors of 145. Is 5 a perfect square? No. 29 a perfect square? No. They are both prime numbers, so that's as good as this gets. What a disgusting square root we have. So our final step, division distribution. And can I actually divide 145 by 8? Nope, because it's trapped under the square root. So negative 1/8 plus or minus radical 145 over 8. So how many roots did we find? X equals negative 1 is 1. Negative 1/8 plus radical 145 over 8 is 2. Negative 1/8 minus radical 145 over 8 is 3. So 3 total solutions. So folks, that wraps up the guided practice.